Okay, some special properties of logarithms. If you have an exponential that's b to the first equals b, well, anything to the first power is equal to itself. The logarithmic form of it would be log base b of b equals 1. So, sorry, whoa, wow. Thinking of the next problem. So, log base b of b equals 1. So, if the base and what's inside are both the same number, it will end up being just a result of 1. So, for example, you could have log base 23 of 23 equals 1. Sorry, waiting for air server to catch back up. Did it freak out on me? Dang. There we go. Okay, I don't feel like re-recording that. So we're going to do log base pi of pi also equals 1. Now, for the exponential form, if it's something b to the 0 equals 1, remember, anything to the 0 power equals 1. If you have log base, who cares, b of 1, that's always going to be equal to 0. So using those same numbers that I had, so, log base 23 of 1 equals 0. Or log base pi of 1 also equals 0. So that's always going to be true. And again, the reasoning for these are, especially in this first corner here, log base 23 of 23 equals 1 because 23 to the first equals 23. Same thing with this, pi to the first equals pi. Down here, this would be like 23 to the 0 equals 1. And this one would be pi to the 0 equals 1. So just kind of translating them back into exponential equations. One thing that you're going to run into, the logarithm with a base of 10 is called a common log. If there is no or common logarithm, sorry, I'm abbreviating that already. If there is no base written, we can assume it's 10. So therefore, if you ever see an example like log of 5, that implies log base 10 of 5. It's kind of similar to like you have square roots. So like if you're to do the square root of 16, you could also do like the third root of 16. You could also do like the fourth root of 16. Well, these two have this little number here called an index. And it's for a square root, it's the most common square root. So it's like it has an index of 2. We just don't write it. So in this case, because base 10 is so common, we just don't write it. So a couple examples here. Log of 0.01. This is exactly what I was talking about a second ago. So this is really saying log, sorry, let me get my writing utensil back out, log base 10 of 0.01. And we're trying to figure out what that's equal to. Now I'm going to translate that back into a fraction. So 0.01, that's 1 over 100. Now this is the first time we've had to solve for a problem like this. We really need to ask ourselves, 10 to what power equals 1 over 100? And in that case, it's negative 2. So in this case, our final answer is just negative 2. So we're essentially solving for that missing exponent. Number 2, log base 5 of 125. Again, similar in this one. 5 to what exponent equals 125? In this case, it is 3. Try the next two on your own, so pause the video. And if you want to convert it to, I would say for number 3, convert it to a fraction first. Okay, back to it. I'm going to convert log base 25, 0.04. That's 4 100ths, which you can convert to log base 25 of 1 over 25. So again, you're asking yourself, 25 to what power equals 1 over 25? And in that case, you just get negative 1. So again, the logarithms, we're just solving for that mystery exponent. So for this bottom one, you're saying 2 to what power equals 64? And that is 6. So we're again solving for these mystery exponents.